All right, so in this video, we're going to look a little bit at a couple more ways of importing data into Python. And then we're also going to look particularly at using SQL queries in Python itself. Now, as my class is continuing, my class is beginning to look at database structures. We've seen some JSON database references in the past. We're also going to be looking in this course at SQL. And so there's going to be some references to that in this discussion and in the next one as well. Now, we are going to be comparing the SQL commands to regular pandas functions. So even if you're not particularly interested in the SQL, you will find some useful pandas functions in here as well. Now, we are going to be importing 2 additional packages that we haven't used before, and you will probably need to install these before they will load properly. So the 2 packages are pandasql, and the other one is SQLite 3. Let me see where it is, way down here, SQLite 3. So both of these functions, both of these packages will have to be imported before they, installed properly, before they can be run. All right, so let's go ahead and get started. So we're going to start by importing pandas, and the file that we're going to be importing the file that we're going to work from is a file, in this case, called absenteeism at work. This is an old style Excel file, not the sort of most recent decade-old XLSX file that we have seen in previous videos. So this one's going to be a little bit different. It uses the same function. Pandas can tell the difference between them and import them correctly. Now, one thing that is a little bit different here is that we're not just using the text string. This R in front of it is telling Python to read this as just a plain text string. Sometimes if you don't use this R string in the front, special characters like the slashes have to be escaped because of the way Python reads these characters. And so if you use the R in front of the file string, you're telling Python to just read it as is and not worrying about those escape characters. So you'll sometimes see this rather than using some extra backslashes and things like that in order to get the characters to read properly. So let's go ahead and import pandas and load this file. Okay, so that error was unexpected, and I have now fixed it. So apparently in the newer releases of Python, they don't have the module pre-installed that you need to read these older Excel files. The package is called XLRD, and you just need to go to Anaconda and install it, just like we are going to have to do for the pandasql and SQLite packages. So it's now working again. My older version of Python did not have this problem, but I guess these versions of Excel are now so old that they have stopped doing them as a default in my newer installation. So here we are. All right, so here is our absenteeism at work file. And again, this is the file that we're going to be using for much of our demonstration today. And it's got quite a lot of information that we can play around with. All right, now continuing then, if we also want to install a JSON file, we can similarly install from pandas the read JSON. We've talked about the JSON formatted files So we have previously talked about the JSON file format. And so we have this test file, which I had forgotten to put in my folder, that is a JSON file format. And when you read it into the read JSON function, it imports it conveniently as a data frame. Now, it's often necessary to import data from the internet. Lots of different places put their files online. And so sometimes you can download those files and then import them from your downloads folder. But you can also sometimes just import them directly from the website. So I haven't downloaded this in a year, so we'll see if it actually continues to still work. So this is a CSV file that we're obtaining from the UCI machine learning database. And so this is the address. It's information on abalone shells. And we're going to only import a certain number of the column names, not all of the ones that are available. So you can list out the values. Again, typically you might want to download the file, see what kind of information is available, and then tailor the working download that you're going to do for the specific things that you want. This usually in standard Zoom levels would fit on the screen, but because I zoomed in order to make the text bigger, it now runs way off the screen. So again, these are the ones that we're importing, and then when we import them, it accesses the database and downloads the column names that we wanted. All right, now we're going to continue then to work on our pandas-SQL. So again, we're going to use pandas-SQL as a way of manipulating data frame using SQL-like commands. So we're going to first need to import pandas-SQL from our memory. So again, remember, you have to have installed this. And we're going to import specifically the SQL as a data frame type of function. So we're going to read in this Excel file that we were looking at earlier, and we're going to save it as our DFP SQL package or data frame so that we can employ it. And then our query strings are going to be essentially put into this pandas SQL type function. We're going to give it a query string in this format with 3 sets of quotation marks on the outside. Our SQL function, as we would type it into any SQL engine, again, enclosed in these 3 quotation marks, and then use this SQL df type function that we imported from pandas SQL in order to perform the operation on the data frame. So let's go ahead and run this. So in this particular function, all it did essentially is what we were doing earlier when we just imported the data from this file. We imported the file, we converted it to a data frame, and then we read the top 5 lines. In this case, we're doing basically the same thing with the pandas SQL function. So the SQL df, we have imported the data frame and saved it as this. And then this query string is basically select star, which means basically everything, from this data frame, from this table, and then limit it to 5. So that this is let's look at the top of the data frame, the head of the data frame. And then the SQL df function is going to take our query string and apply it to our data frame and spit it out into our Python. So again, we have this same operation in pure pandas, but now we're using it to experiment with our SQL commands. Now, the DFP is the same data frame that we were using, that we imported earlier, the same file. And so this is a filtering process. In this case, we're going to take our data frame that we were looking at before, our absenteeism data frame, and we're going to limit the ages to those that are greater than 30 and less than 45, so between 30 and 45. So we have a combination filter here. We're going to look at the data frame where age is greater than or equal to 30, and we're also going to look at the data frame for all the ages that are greater than or equal to 45, and we're going to select those that are in both of those camps, so between 30 and 45. And again, this is the pure pandas way of looking at this. And so if we go through and we look for our ages, which is too big on the screen, there we go. These are all of our ages, and you can see they do appear, the ones that are displayed, they do appear to be in the range that we indicated. Whereas in the past, if we look at our previous import at the age column, we have some in that database that are in fact over 45. And now we appear to only have those that are between 30 and 45. Now to do this in SQL, again, select star just means select all the columns from this table, the DFP SQL. And again, these are the same data frames. We just save them as slightly different things to keep them separate so that if we modify one, we're not modifying the other. And then the filtering function is we would use where age is greater than or equal to 30 and age is less than or equal to 45. Again, our query string, we've enclosed it inside these triple quotes. And then this SQL df function is going to apply that to our DFP SQL data frame. And we should get the same outcome here is our ages, and they do appear to be the same values we had before. Now, I can use this unique function if I want to select only those things that are not repetitive. So in this particular case, I want to go through my absenteeism database, and I want to pull out just the people who have been absent, not the number of times that they've been absent, but just their individual ID numbers. If they are on the list, I want them to be listed one time, not multiple times. So that's what this .unique function is for. So you would select your column, and it will give you the unique values that appear in that column. And so this is printed as an array. These are the individual employee IDs of the people that have been absent at least once. Now in SQL, we will do this with the distinct function. So we will select distinct ID from the data frame. Now notice that here we're not using star, we're just using this one column, the ID column, and then we're saying, don't give me the whole column, just give me the distinct values from that column. So that's equivalent to our unique function. And we should be able to see that these are, in fact, the same 11, 36, 3, 7, 10, 20, and so forth. Now, one of the nice things about the SQL pandas SQL function is that the output of this process of the SQL df function is that it does in fact output data frames. And so data frames are convenient things for us to work with in Python, especially in the data science context. Now, if I want to select people from my database that are just within a particular list of values, not a range of values. So we saw earlier we wanted ages that were between 30 and 45, but now I only want ages that are exactly 20, 30, or 40. So maybe it is a company tradition that you are going to give, decade birthday parties special. Maybe you don't do it when they're 31 or 32, but you do it when they turn the big 40. You want to select only those particular ages, not everybody in between a range. So here you would use, in pandas, you would use the is_in function, and then you would list the values. So essentially this is saying, if it's 20, I want to pull those. And if it's 30, I want to pull those. And if it's 40, I want to pull those. So you could easily construct, similar to what we were doing before, that filter function but you would just have, in this case, you would have three distinct or operations in this case. So if they're 20, or if they're 30, or if they're 40. And so it's just a little easier to construct this is in list. It's those or operations are already built in. And so again, we picked age. And let's just go look at our age column. And you can see that in this age column, we have only people who are 40, 30, or presumably there's some 20-year-olds in there. Now, one other thing to kind of note is this way of referring to the column name, dfp.age. So this is the data frame name, and then dot the column name. And then the dot that follows is the method that we're using. This is in operation. Now, one thing to kind of keep in mind is that this will work as long as the column name has no spaces. If it has spaces, then you need to use something more like this in order to do this operation. So, but this is a convenient way of looking at of calling these column names with a little bit less typing. Now, to select the same data from the table using SQL commands, we would say select star because we're taking every column from our table where age is, and there's no is, in, and then we would again have a list of the values that we were looking for. And notice that our SQL functions, they all end with this semicolon. And again, we would get this table, and let's look for our age column. And we can see that these are the same age values that we had from the pandas command. Now, if we want to select everybody but the people in these three age groups, then we would use this tilde in front of our filter, in the tilde above the next to the 1 key. This is going to do the negation of this operation. So essentially what we're saying is find all the 20, 30, and 40-year-olds and then remove them from our data frame. Again, let's look for our age column. So we do have a 50-year-old, but we don't have any 20, 30, or 40-year-olds. And then again, similarly, we could do the same thing in SQL, but now we're doing age not in this list. And if we scroll over to the age column, again, this list matches the list that we had in the previous example. All right, so now we're going to do sorting. So we looked at sorting in a previous video, but since we're comparing it to the way that SQL commands work, we're going to do it again. So this is our data frame. We're going to sort values, and then we're going to sort them into two columns. So we're going to sort them first by age, and then if their ages are the same, then we're going to sort them by service time. And we've selected ascending equals true, so that's going to start at the youngest age and work its way up. And again, if we sneak over to the age column, We started with the 27-year-olds and we've ended with the 58-year-olds. And service time, these are all people who have 7 years. This may, in fact, all be the same person. Because if they're absent more than once in this data set, they will appear each time they're absent. And again, a 58-year-old who's been there 16 years. Now, to do this in SQL, again, we're selecting all of the columns from our table, and we're ordering by, and then age, comma, service time. So instead of sorting, we are ordering, but the same thing. And again, if we scroll over to age, again, we get the same outcome. The 27-year-old is first, and the 58-year-old is second. Now, if we want to sort in the reverse order, in descending order, apparently I can't spell, in descending order, then all we would do in pandas is we would change ascending equal to false. And so then it will start with the 58-year-old. And we can see our 58-year-old is now first and the 27-year-old is last, as opposed to before it was the reverse. In SQL, you have to be a little bit more careful. In pandas, it's going to assume that you mean descending in both directions when you say false. But in SQL, you have to specify age descending and service time descending. So this DESC is going to tell SQL that you are descending order and not ascending order. Ascending is the default. And so if we run that, we will again get the same outcome that we had before. And feel free to experiment with this to see if you can do age ascending and service time descending or vice versa. Now, another thing that we can do is aggregate values. So we can collect things according to a particular column. We can calculate a count. We can calculate the minimum, the maximum, various other functions. So in pandas, we're going to specify the column name that we want to do our aggregation on, and then specify the list of operations that we want to conduct. So here we're going to calculate 4 different statistics about our transportation expense column, the count of them, the minimum, the maximum, and the mean. And so you can do other common statistics here, like medians and standard deviations and so forth. And so what we end up with is we end up with a table that's calculated. There are 740 transportation expenses. The minimum is $118. The maximum is $388. And the mean is around $221.33. Now, this is a little harder to do in SQL because you have to specify the column. Each time you calculate something on it, you have to calculate it separately. So here we're selecting and then count of transportation expense, and then we're going to call it count. So saying as count is what it's going to go, what we're going to name it in the output. Otherwise, the name of the output would be count transportation expense. It would be this whole thing here. So we're going to rename it as count in order to put it into the output. Same thing for minimum transportation expense. We're going to relabel that as min. We're going to calculate the max transportation expense and relabel that as the max. And then the average transportation expense as the mean, and then from our data table. make sure we have the right name of the table. Not that it matters because it's the same table. And then same thing, we'll run that query string on our data frame. And so we get our count, our min, our max, and our mean. Now, one thing you may notice is that the format came out a little differently. So this is horizontally oriented and not vertically oriented. And I didn't get floats for the count, the min, and the max, although I did for the mean. So sometimes that formatting difference can make a difference in how you display the data. So minor differences, but we did get all the same values. Now we've looked at group by before. In this case, we're going to group by ID. We're going to use the service time column, and then we're going to collect the sum. And so the ID service time, we're adding up those service times that they appear in the database. Notice this did not return this information in a standard data frame based on the way that it's output here. Now, if we do this in SQL, then we're going to select our ID. The ID column is what we want it to output. And we're also going to output the sum of service time. And then we're going to change the title again as instead of printing sum service time, it will print sum underscore service time. And then we're going to group by ID. So again, this is output as a data frame. But it's the same information we had in the previous command. Here, we're going to use group by and also aggregate at the same time. So we're going to group by their reason for absence, and then we're going to aggregate on age, their mean, the min, and the max. So their reason for absence, there are several reasons for absence. We would need information on exactly what these stand for, but there's 28 of them. And then the age information, who is taking these reasons for absence. So it's interesting to see that, for instance, the different ages that take different reasons for being out. And apparently some of them are not used very often because there's only one person using them. Now, if we were to do this in SQL, we're going to select the reason for absence, and we're then going to average the age, and then again, rename that as the mean. We're going to take the minimum of age and rename that as the min, the maximum of age, rename that as the max. And then group by reason for absence. So these calculations that we're doing are the aggregation functions, and the grouping is being done by the reason for absence. And again, we get the same information as in our previous function. All right, now we're going to continue our example with a different data set. We're going to look at how joins work. And so in order to do our join examples, we're going to create some artificial data. So we're going to create this data as a data frame. So you don't have to re-import pandas once you've done it, but I'm using this as a particular example that was originally a standalone example. And so we're re-importing pandas. You can leave that off when you do this all together. So we're going to create our first table, and we're going to have a list of employee IDs, 11, 10, 11, 10, 12, 10, 13, 10, 14, 10, 15. We've got some names for our people and their designations: manager, research engineer, VP, and delivery manager. Date of joining. We have some dates. And then we're going to take this data that we've created and we're going to name the columns, and we're going to turn that into a data frame. So this is our little mini data frame. And now we have a second set of data. We have employee IDs with no names. We do have departments: management, research, management, delivery. We have years of total experience. And we're also going to create that into a table in the same fashion. So our data, our columns, and then we're going to turn it into a data frame. And so you can think of these as two tables in our imaginary database that we're going to now try to combine in some meaningful way so that we can, we know how long Rahul has been working at the company or how long Morty has been working there, since that information wasn't in the original table. All right, so now that we have our two tables, we want to look at some of the joining operations. Now you can do join-like operations both in pandas and of course in SQL. And so in pandas, you're going to use the merge function. So there are different kinds of joins that you can use. An inner join is going to only include information that is available in both tables. So typically when you do a joining operation in SQL, you specify two tables. And so the one that you list first is the left table, and the one that you list second is the right table. And so there are actually differences in how the joining operations can work depending on the order that you specify. Now, not for inner joins, this won't really make that much difference, but you can do left joins or right joins, and then it would matter what the outcome looks like. But this is an inner join, and we've just listed the left table, the employee ID table, and then the two tables, employee ID and department. And then what we're going to do is we're going to specify which columns we are doing the joining on. So the columns that they have in common is the employee ID column. And so that's how we're going to identify how they match. So we're going to run that. So there were only 3 people that were listed, 3 employee IDs that were in common in both tables. And so they've only given us the table information that is fully complete. That's how the inner join works. So if the ID doesn't appear in both tables, it just gets dropped. Now, to do this in SQL, we would select star because we're, again, using all the columns from our employee data frame, and we're going to call that A. So just list A after the name of it. Inner joins, because we're doing this inner joining operation on the department DF. And again, we're going to label that as B in any future functions. On, so what columns are we trying to match? A dot employee ID. So this is where that A comes in. Otherwise, we would have to type out employee df dot emp ID. And then equals on the other side, again, what are we matching? B is referring to the department df. If we didn't specify this B, we would have to type out department df dot emp ID. And then we're going to run that. And again, we get the same outcome. Now, when we do a left join, the code is basically the same, but what's going to happen in the output is that anything that's in the left table is going to be preserved. And if there's no information in the right table, then it will get filled in with NAs, with not availables, not a number type of outcome. Right joins will do the reverse. They will keep everything in the right table, and then they will fill in NAs for things that are missing in the left table. So here, everybody who had a name in the original table is listed, all 5 of our people, but there's 2 people, Morty and Rahul, who we don't know what department they're in, and we don't know how long they have been working there, how long their total experience is in the field. Now, again, to do this in SQL, again, the code is almost exactly the same, except that you change inner join to left join. Everything else is exactly the same from our previous example. And we get the same outcome. Now notice that in the pandas one, we get NaN, whereas in the SQL one, we get none. But another difference that we can see is that in the SQL version, the employee ID that joined the 2 tables is actually here in both tables. It's actually listed twice, the original one and this new one. Now, if we do this as the right join, again, the thing that's going to be preserved is the right table, and then NAs will get filled in the left table. So here we've got employee IDs, but we don't know what their names are in some of these cases, or what their titles are, or when they joined. We just know there are some people in management and research that were not in our other table. And again, the right join, the easiest way to do a right join, honestly, is just to flip your table names, the order that you do them, and just do a left join. But we'll see in SQLite, we don't actually have a right join. And so the only way that you can actually do a right join is a left join, but with the tables in the opposite order. Here I've changed the function up just a little bit. Here I'm selecting the employee ID, the name, the designation, the date of joining, the department, the total experience. I'm listing out all of the individual columns that I want to keep from department DF. And partly this is going to allow me to make sure that that duplication of the employee ID doesn't happen. And then I'm going to do a left join and then match my 2 columns. And again, by switching the order, then I can control whether the left join is going to primarily join on one table or the other. Now, an outer join is going to keep information from both tables. So it will have NAs potentially in anything that doesn't match up between them, but it will preserve all of the information, not just the information that's complete in one table. So again, we're using the merge function in pandas, and we're only changing the how to outer. So for some of our people, we have NAs from the second table. And some of our people, we have NAs from the other table. But we have a complete list of the employee IDs that we did the joining on. Now, same thing for our SQL function. The outer join is going to, again, it's going to preserve all the information from our two tables. Yeah, I got an error on that. That's weird. All right, so moving on, we also want to be able to do some of these functions using the package SQLite. Now, the advantage of SQLite is that it actually works like a database. You can have a SQLite database, and even though it doesn't have all the functionality of a full like Access database or a MySQL database, it can only use one user at a time, and so on and so forth. It only has limited numbers of joining operations, for example. Nonetheless, it can maintain multiple tables in the database at the same time, and we can use it to practice our SQL functions. Now, again, this one you do need to install in Anaconda. When I installed it on this particular computer, the pip install didn't work, but the Conda install did. So if you get an error in one of them, try the other one. And I'm not going to run this because, again, it's already installed on my machine. So I'm just going to import it. And we're going to essentially connect to our SQLite database. Now, this database I took from Access. It was the school schedule database, and I simply exported it from Access into a SQLite format. So this should be something that you could find either in your Access program or on the Microsoft Office website. And then again, I just used Access, exported it as a SQLite database so that I could work with it here. Now we're going to create a con, which is short for connection. So we're going to connect to our SQLite database, and then the cursor is going to allow us to execute functions. Now, the raw way that this works is not going to be very convenient. It's going to output things in a format that is not particularly useful. So we're going to write a small function in a bit to help us manage the conversion from this nasty format to something that is easier for us to work with, like a data frame. But we're going to first see what it does raw. Now, I'm going to use Q as the name of my query. And we don't have to put these in triple quotes like we did in the pandasql package, just single quotes. It's a text string. And we're going to select star from the table faculty. So faculty is one of the tables that's in this database. And then we're going to execute that query. And then we're going to print out the results. And as you can see, it comes out in this weird format. Nasty. This is not helpful or particularly useful for us to work with. And so we're going to convert this into a pandas data frame using this pandas function called read SQL query. And so what that's going to do is it's going to connect our string that we're going to give it our query string, and it's going to read it to the connection to the SQLite database. and then it's going to output it as a pandas data frame. So our little function is, and I'm just calling it X because I'm too lazy to type out a bunch of stuff, which is a bad naming convention if you're using a lot of functions, but this is for preserving my sanity when it comes to typing. We're just going to call the function X, and the X is going to take the query string, and it's going to return that query string in that connection converted to a data frame in pandas. So we're going to import this function, and then we can run a bunch of queries we can just import plain text, or we can specify the string and then just run it that variable name through the function. So here I'm going to select all the columns from my faculty database, and I'm going to limit them to a certain number. So it's the same output from before, except I'm only taking 6 of them and not all of them. And now we can see this is in a much easier way for us to work with it. Again, this is not this like string of list values, crazy. This is not helpful. This is much easier for us to perform further operations on if we wanted to sort it or graph the information or anything like that. We now have something that's easier for us to work with. Now, I'm going to now count the number of titles from the faculty. So how many different faculty titles are there? So there's 24 different titles in the faculty database. If I want to know, so I think that just means there's 24 faculty in the database. If I want to count the distinct titles from the database, so how many different titles are there? There's only 3. So one might presume assistant professor, associate professor, and full professor. Or maybe maybe one of them is an adjunct. Who knows? We could look at the whole table and we could see, but we're not going to worry about that right now. We can also count distinct title as ranks from faculty. So again, what we're doing here, notice that if I don't use the as something, then it just uses the function name that I use to generate that from SQL. Count distinct title is not really very meaningful. So I can rename it as ranks, and then it will tell me it'll rename the title in the label on my output as ranks. Again, select average salary from faculty. The outcome will be listed as average salary. So this exact SQL command that you used, 51,000 is my average, give or take. Select star from student schedule. So there are many, many tables in this database. So we're just pulling out an example of the student schedules. From class sections, now one of the advantages of looking at some of this data in, let's say, Access is that you can see all the names of all the tables and easily sort of flip back and forth between them to see what kinds of tables are available to pull from and what kind of information is available in each of the tables. So if you're working with a database like this in Pandas, it might be useful to extract at least examples of like the heads of all the different tables so that you can easily refer back to them. Sometimes you might be able to open the database in Access on one screen and then work with it on the other screen. But here I've listed the available tables: buildings, classrooms, class sections, course categories, courses, departments, faculty, faculty categories, faculty courses, faculty sections, student schedules, and students. So there's a lot of different tables in this database. And so that, again, you can pull them into Python in order to have them as a reference. Now here we want to combine some of our categories. We want to do joins on some of these tables so that we can get information from them. And you can do multiple joins. You don't have to just join just two tables. You can join multiple tables together. Now, a natural join is essentially going to see which two columns in the tables are similar and then automatically join on those two columns. Now, this will work just fine where the naming conventions are consistent from table to table to table. If they are not consistent, then as with our previous examples, you will have to specify which columns you are doing the joining on. If they're named differently, you are absolutely going to have to specify them. You won't be able to do the natural join. But in the school table, these are very well named, and so we can use the natural join without having to specify constantly which table, which column names they need to match up. So we're going to select all the columns from class sections joined with courses, and we're going to limit our selection to the math category. So this will be a combination table. And you can see that all the information in here, these are all math courses. If I don't include that where, then I will get all possible courses. Again, here we're going to select average credits, average duration from the class sections, joined on courses, and specifically we're going to look at, again, the math courses. So we want to know how long are these courses, what's the average number of credits, and how long does it normally meet. I assume this is per class period. So this would suggest that most of the courses in the department are probably 5 credit hours with a couple that are not. And then here we're going to select, again, average credits, average duration from class sections. And here we're going to compare the results to the art department. So smaller number of credits, longer class periods. As I recall from school, art classes were considered more like lab classes. You didn't really have a lot of homework, but you had to spend more time in class to have access to like the still lives or the life models or what have you in order to do the work. Here we're going to select category ID, average credits, renamed as mean credits, joining class sections on courses, and we're going to group by category ID. And again, here I'm saving my outcome as a data frame so that I can, in the next step, potentially plot it. So these are my mean credits by category ID. So we can see the math is the same that we had before, and art is also the same as we had before. And now if I want to plot this, I'm going to go back to Seaborn, and I'm going to use my cat plot function, and we're going to plot this as a bar graph. And so similarly, we can select an entire table and save that as a data frame that we can then work on with our other functions. All right, so that was kind of long, but that should give you some sort of introduction to working around, not only working with pandas, doing SQL-like functions, but then also working with SQL commands and performing operations on it in Python. And then we will continue in the next lecture with SQLite, and we are going to use it to build a database.